Welcome back to my channel, Trash to Teach.
The future of serverless computing. 2025 and beyond. Serverless computing is here to stay. But what if I told you the version we know today will be obsolete in just 5 years? Get ready, because we're diving deep into the radical transformations set to redefine cloud architecture. This isn't just an evolution, it's a revolution, and you won't want to miss where serverless is truly headed. Hey everyone, welcome back to the channel. We break down complex cloud technologies and help you stay ahead of the curve. Today, we're tackling one of the most transformative technologies in modern computing, serverless architecture. And this isn't going to be a surface-level overview. We're going deep, really deep. Over the next hour, we're going to explore every facet of serverless computing's future, from technical innovations to business implications, from edge computing to AI integration, and everything in between. Make sure to hit that subscribe button and ring the bell so you don't miss any future deep dives like this one. And if you find this video valuable, drop a like. It really helps us reach more developers and cloud enthusiasts like you. Here's what we're covering today: the complete current state of serverless and where we stand in 2025. How serverless is expanding far beyond simple functions, the convergence of edge computing and serverless AI and machine learning's explosive integration with serverless, the dramatic evolution of developer tools and experience real-world case studies from companies at the cutting edge, honest discussion of challenges, and when not to use serverless bold predictions for the next 5 years, practical strategies for individuals and organizations, and a lot more. Grab your coffee, get comfortable, and let's jump in. Section 1. The Serverless Revolution, Where We Are Now. Let's start at the beginning. To understand where serverless is going, we need to understand where it came from and where we are today. Serverless computing as we know it really kicked off in 2014 when AWS launched Lambda, but the concept goes back further to platform as a service solutions like Heroku and Google App Engine. What made Lambda different was the granularity. You weren't deploying apps, you were deploying individual functions. The promise was revolutionary. No servers to manage, pay only for compute time you consume. Automatic scaling from 0 to thousands of requests. Built-in high availability, what serverless actually means. Let's clear up the biggest misconception right now. Serverless doesn't mean there are no servers. Of course, there are servers running your code. The term serverless refers to the developer's perspective. You don't see, manage, or think about servers. They're completely abstracted away. In traditional cloud computing, you provision virtual machines, you choose instance types and sizes, you manage operating systems and patches, you configure auto-scaling rules, you handle load balancing, you monitor and maintain everything. In serverless, you write code, you deploy code, that's it. The cloud provider handles everything else: provisioning, scaling, patching, load balancing, availability. You focus purely on business logic. The core benefits that changed everything. 1. Cost efficiency. This is often the first benefit people mention, and it's powerful. With traditional infrastructure, you pay for capacity whether you're using it or not. Your servers sit there at 3 a.m. consuming resources and costing you money even if nobody's using your application. With serverless, you pay for actual execution time, measured in milliseconds. If your function isn't running, you pay nothing. For applications with variable or unpredictable traffic, this can reduce costs by 70 to 90%. Real example: a startup I consulted with was spending $3,000 monthly on EC2 instances that were idle 80% of the time. After migrating to Lambda, their compute costs dropped to $400 monthly. Same functionality, same performance, but they only paid for what they used. 2. Automatic scaling. This might actually be the most powerful benefit. Scaling traditional infrastructure is complex. Set up auto-scaling groups, define scaling policies, configure health checks, test scaling behavior, optimize for cost versus performance. With serverless, scaling is automatic and instantaneous. Your application can handle 10 requests per day or 10,000 requests per second with zero configuration. The platform handles everything. Real example, a media company I worked with had an article go viral. Traffic spiked from 1,000 to 500,000 requests per hour in minutes. Their serverless infrastructure scaled automatically without any intervention, without any downtime, and without over-provisioning expensive capacity, just in case. Third, developer productivity. This benefit is harder to quantify but potentially the most valuable. When developers don't need to think about infrastructure, they can focus entirely on solving business problems. Time spent on server provisioning, eliminated capacity planning, eliminated OS updates and patches, eliminated security hardening, reduced deployment complexity, reduced monitoring infrastructure health, reduced. Companies report 40 to 60% faster time to market for new features when using serverless architectures. That's a massive competitive advantage. Fourth one is built-in reliability. Serverless platforms are built on top of highly redundant infrastructure. When you deploy a Lambda function, it's automatically distributed across multiple availability zones. If one zone fails, your function keeps running. You get enterprise-grade reliability without enterprise-grade effort. Next is current state of adoption, the numbers. According to recent industry surveys, 71% of organizations are using serverless in some capacity, 45% have serverless in production for critical workloads. Serverless adoption grew 75% year over year in 2024. The serverless market is projected to reach $30 billion by 2026. Major enterprises leveraging serverless at scale. Netflix uses Lambda to encode video files, manage ETL processes, and handle billions of API calls. Coca-Cola migrated vending machines to serverless, saving 65% on costs. Capital One runs critical financial services on serverless architecture. iRobot powers cloud services for robot vacuums with Lambda. Airbnb uses serverless for search, recommendations, and payment processing. The major cloud platforms, recent innovations. Now supports up to 10 gigabytes of memory, improved cold start times by 80% in the last 2 years. Lambda Snap Start for near instant Java. Cold starts Graviton. 2 processor support for better price performance. Lambda function. URLs for direct HTTPS endpoints. 15-minute maximum execution time. Flex consumption plan with dynamic scaling. Premium plan with always warm instances. Durable functions for complex orchestration. Strong integration with .NET ecosystem. Virtual network integration for hybrid scenarios. Cloud Run supporting any containerized application. Second-generation execution environment, concurrency up to 1,000 requests per instance. Minimum instances for eliminating cold starts. Direct VPC integration, WebSocket support. Deploy to 300 plus global locations in seconds. V8 isolate technology for near zero cold starts. Durable objects for stateful edge applications. R2 storage integration, real-time serverless at the edge. Let's discuss. Each platform has strengths. AWS is broadest service integration. Most mature ecosystem. Azure is best for enterprise and hybrid scenarios. Google is Kubernetes native, great for containers. Cloudflare is unmatched edge performance and global distribution. Common misconceptions still lingering. Even in 2025, there are still myths about serverless we need to dispel. Myth 1. Serverless is only for simple applications. Reality. Companies run complex mission-critical systems entirely on serverless. We're talking about financial transaction processing, real-time data pipelines, and enterprise SaaS platforms. Myth 2. Serverless is always cheaper. Reality. For high-volume, consistent workloads running 24/7, traditional infrastructure can be more cost-effective. Serverless shines with variable or unpredictable workloads. Myth 3. You can't do stateful applications with serverless. Reality. While functions themselves are stateless, you can build stateful applications using databases, caching layers, and state management services. Entire e-commerce platforms run on serverless. Myth 4. Serverless means vendor lock-in. Reality. There is some lock-in, but it's decreasing. Modern frameworks, containerization, and standards like WebAssembly are making portability much easier. Why understanding the future matters. Here's why spending the next hour understanding serverless's future is crucial. Career impact. Serverless skills are increasingly in demand. Understanding where the technology is headed positions you for opportunity. Business strategy. Architectural decisions made today impact your organization for years. Choosing the right approach now saves millions later. Competitive advantage. Companies that master serverless can move faster, scale better, and operate more efficiently than competitors stuck on traditional infrastructure technology convergence. Serverless is intersecting with edge computing, AI, IoT, and other major trends. Understanding these intersections is where the real value lies. All right, foundation set. Now let's dive into the future. Next is Section 2, Beyond Functions, the expanding serverless landscape. The original FaaS model and its limitations. When most people think serverless, they think functions as a service, FaaS. You write a function, it executes when triggered, it terminates. Simple, elegant, powerful. But this model has real constraints, time limits. Most FaaS platforms limit execution to 15 minutes. That's fine for handling API requests or processing events, but it rules out long-running tasks like video encoding, complex data processing, or machine learning training. Statelessness. Functions are ephemeral. They start fresh every time. You can't maintain connections, cache data locally, or preserve state between invocations without external services. Cold starts. When a function hasn't been invoked recently, the platform needs to initialize a new execution environment. This takes time, sometimes hundreds of milliseconds or even seconds. For latency-sensitive applications, that's unacceptable. Resource constraints, limited memory and CPU options. You couldn't run resource-intensive workloads effectively. Language and runtime limitations. You're constrained to supported runtimes. Want to use a niche language or specific system dependencies? Good luck. These limitations meant serverless was perfect for certain use cases, but completely unsuitable for others. That's changing rapidly. The rise of serverless containers. The game changer has been serverless containers. Platforms like AWS Fargate, Google Cloud Run, Azure Container Apps, and others let you run full containerized applications with serverless characteristics. What this means in practice, package your entire application as a Docker container. Deploy it to a serverless platform. Get automatic scaling from 0 to thousands of instances. Pay only for actual usage. No infrastructure to manage. The key advantages: 1. No refactoring required. You can take existing applications, containerize them, and deploy them serverless. No need to break everything into tiny functions. Your monolith, it can run serverless now. 2. Long-running processes. Cloud Run supports execution times up to 60 minutes. Fargate has no hard time limit. You can run batch processing, video encoding, or complex computations. 3. Stateful applications. Within a container instance, you can maintain state, cache data, keep database connections alive, and preserve context between requests. 4. Complete flexibility. Use any programming language, any framework, any dependencies. If it runs in Docker, it runs serverless. 5. Gradual migration path. You don't need to rewrite everything. Containerize your existing apps and gain serverless benefits incrementally. Real-world case study: serverless containers in production. Let me share a real example. A fintech company I consulted with had a complex transaction processing system built in Java. It was running on EC2 instances that cost $15,000 monthly. The system had variable load, extremely busy during market hours, almost idle overnight, and on weekends, they were massively over-provisioned. Traditional approach: break everything into Lambda functions, rewrite large portions of the code base, deal with cold start issues for latency. Sensitive processing modern approach: containerize the existing application, deployed to AWS Fargate, added auto-scaling policies. Results: Zero code changes required costs dropped to $6,000 monthly. Automatic scaling during peak hours. Scales to zero overnight. Actually zero. They pay nothing when markets are closed. Deployment pipeline remained the same. This is the power of serverless containers. All the benefits, none of the constraints. Serverless. Beyond compute. The full stack goes serverless. But wait, it gets even better. The serverless model is spreading to every layer of the stack. Serverless databases. Traditional databases require provisioning, capacity planning, maintenance, and scaling. Serverless databases handle all of this automatically. Amazon Aurora Serverless v2 is scales from 0.5 to 128 ACUs automatically, scales in fractions of a second, pay only for capacity used, and supports MySQL and PostgreSQL. Next, Azure Cosmos. DB Serverless is pay-per-request pricing, no capacity planning required, global distribution, and multiple consistency models. Neon Postgres is serverless PostgreSQL, with branching, scales to zero when inactive, instant database copies for development, and pay only for storage and compute used. PlanetScale, MySQL, is serverless, MySQL at scale, non-blocking schema changes, branching for development workflows, and query insights and optimization. Real Impact, a SaaS company running PostgreSQL on RDS, was paying $800 monthly, even though their database was barely used. Switched to Neon, costs dropped to $120 monthly, with better performance during peak times. Serverless data warehousing is Google BigQuery. That is serverless data, warehouse at petabyte scale, pay per query, or flat rate pricing, no cluster management, automatic replication and backup, BI engine for sub-second analysis. Snowflake can separate storage and compute, scale compute independently, pay only for queries executed, automatic optimization. Amazon Redshift Serverless is data warehouse with no provisioning, automatic scaling based on workload, compatible with existing Redshift tools. Pay per RPU Redshift processing unit. Serverless message queues and event buses. Our Amazon Event Bridge that is serverless event bus route events between AWS services and SaaS apps. Schema registry and discovery archive and replay events. Google Cloud PubSub is serverless messaging. Global by default at least once delivery. Dead letter queues. Azure Event Grid can do event routing at scale. Filter and route events. Cloud events schema support. Serverless storage. Amazon S3 can infinitely scalable object storage. Multiple storage classes. Intelligent tiering event notifications. Cloudflare R2 is S3 compatible object storage. Zero egress fees. Global distribution edge integration. What this all means, you can now build entirely serverless applications, and I mean entirely. Compute, serverless functions or containers. Handles your application's logic, e.g., APIs, background jobs. Examples: AWS Lambda, Google Cloud Functions, or Fargate, serverless containers. You upload code, the platform runs it on demand. Database, Aurora Serverless or Neon stores your application's data. Aurora Serverless, AWS, and Neon, Postgres-based, automatically scale capacity and pause when idle. No database servers to manage caching. DynamoDB or Redis Cloud. Keeps frequently accessed data in memory for fast retrieval. Both options can scale automatically and are managed services, no setup or tuning of servers. Storage, S3 or R2, for files, images, videos, or backups. Amazon, S3 and Cloudflare R2 are serverless object storage systems that handle infinite scalability messaging. Event Bridge or PubSub, for communication between different parts of your app. Events, queues, async tasks. These are event-driven and scale automatically authentication, Cognito or Auth0. Manages user signup, login, and permissions without you building auth logic. Fully managed identity services that integrate easily with serverless backends. Monitoring CloudWatch or Datadog tracks, logs, metrics, and performance automatically. You don't run your own monitoring servers, just plug in and observe CDN, CloudFront or Cloudflare. Distributes your web app or static assets globally for speed and reliability. Also serverless, automatically scales based on global traffic. Every layer is serverless. No servers to manage anywhere, just your code and your logic. Real-world serverless first architecture example, modern e-commerce platform. Front-end, Next.js static site on Versal Edge, functions for personalization. API layer, AWS Lambda, functions with API gateway. Or Cloud Run containers for complex logic. Data layer, Aurora Serverless for transactional data, DynamoDB for session state, S3 for product images and assets. Processing, SQS for order processing queue, step functions for order orchestration, Lambda for payment processing, Analytics, Kinesis data, Firehose for clickstream BigQuery for analysis, Looker for visualization operations, Zero servers to patch automatic scaling for Black Friday traffic. Pay only for actual usage, built-in high availability. This architecture can handle 10 orders per day or 10,000 orders per minute with identical operational complexity, 0. The shift in mindset. This expansion beyond simple functions represents a fundamental shift. We're moving from serverless is a tool in the toolbox to serverless is the foundation of modern cloud architecture. In 5 years, the question won't be, should we use serverless? It'll be, what's your reason for not using serverless? Section 3, the Edge Computing Convergence. Now let's talk about what might be the most exciting and transformative development in serverless computing, the convergence with edge computing, understanding. Edge computing first, let's make sure we're on the same page about what edge computing actually means. Traditional cloud computing. Your application runs in regional data centers. When a user in Australia accesses your application running in US East 1, their request travels 15,000 plus kilometers. That's a lot of latency. Edge computing. Your application runs in hundreds or thousands of locations globally, close to end users. That user in Australia, their request hits a node in Sydney, maybe 50 kilometers away. The result, latency drops from 200 plus milliseconds to single digits. Why Edge plus serverless is powerful. Edge computing and serverless are a perfect match. Serverless provides automatic scaling at each location, no infrastructure management, pay-per-use economics, rapid deployment. Edge provides minimal latency, data sovereignty compliance, reduced origin server load, better user experience globally. Together, they enable truly global low-latency applications without the complexity of managing infrastructure in multiple regions. The major Edge serverless platforms. 1. Cloudflare Workers. This is the platform that really kick-started the Edge serverless revolution. Key features: deploys to 300 plus cities globally in under 30 seconds. V8 isolate technology means near zero cold starts, typically less than 1 millisecond. Handles millions of requests per second. Pay 50 cents per million requests, 50 milliseconds. CPU time per request. Supports JavaScript, TypeScript, Rust, C, C++. Why it's revolutionary. Traditional serverless functions might cold start in 100 to 500 milliseconds. Cloudflare Workers cold start in less than a millisecond. For most users, they're already running. The V8 isolate model is the secret. Instead of spinning up entire containers, they use lightweight V8 isolates, the same technology that powers Chrome. These start nearly instantly and use minimal resources. Real-world example. An e-commerce platform I advised was using API Gateway plus Lambda in US East 1. Users in Asia experienced 200 to 300 milliseconds latency just for network round trips. They migrated authentication, product catalog API, and shopping cart logic to Cloudflare Workers. Asian users now experience 15 to 30 millisecond response times. That's a 10 times improvement in perceived performance. Conversion rates increased by 12% in Asia-Pacific markets. Better performance literally drove more revenue. 2. AWS Lambda at Edge and CloudFront Functions. AWS has 2 Edge serverless offerings with different characteristics. CloudFront Functions runs at 400 plus Edge locations. Extremely lightweight, max 10 KB code size, sub-millisecond execution, best for URL rewrites, header manipulation, request routing pricing, 10 cents per million invocations, Lambda at edge, runs at regional edge caches, 13 locations, more powerful, up to 50 MB code size. Access to Node.js and Python runtimes. Can make network requests best for complex logic, API calls, authentication. Pricing, standard Lambda pricing, plus CloudFront costs. Use cases, A/B testing based on user attributes. Custom authentication at the edge. Image optimization and resizing SEO optimization. Bot detection and filtering personalized content delivery 3. Versal Edge. Functions built specifically for modern web development, tightly integrated with Next.js and other frameworks. Key features, deploys to global edge network TypeScript and JavaScript support. Edge config for fast data access, middleware for request-response modification, tight integration with React server components. Streaming responses, best for modern web applications, Jamstack architectures, Next.js applications, developer-friendly deployment, why developers love it, deploy with Git push. That's it. The developer experience is phenomenal. You get global edge distribution without thinking about it. 4. Deno Deploy. The new kid on the block with impressive capabilities. Key features, TypeScript native runtime, deploy to 30+ global regions, zero config deployments, direct GitHub/GitLab integration, web standard APIs, excellent TypeScript performance, unique aspects, built on Deno runtime, which is designed from the ground up for serverless and edge computing. Secure by default, TypeScript native uses web standard APIs. The technical advantages of Edge Serverless. Let's get technical for a moment about why Edge Serverless is architecturally superior for many use cases. 1. Reduced network latency. Physics matters. Data traveling at the speed of light still takes time. Here's the reality. San Francisco to Sydney. Approximately 180 milliseconds round trip London to Singapore. Approximately 160 milliseconds round trip New York to Tokyo. Approximately 200 milliseconds round trip. With edge deployment, local edge to user, 1 to 15 milliseconds, typical 10 to 20 times latency reduction. Feels instant to users too. Improved time to first byte, TTFB. TTFB is critical for perceived performance and SEO. Traditional serverless, network latency, 150 milliseconds API, gateway, 10 milliseconds, Lambda. Cold start, 200 milliseconds, Lambda execution, 50 milliseconds, total, TTFB, 410 milliseconds. Edge serverless, network latency, 10 milliseconds. Edge cold start, less than 1 millisecond. Edge execution, 5 milliseconds. Total TTFB, 16 milliseconds. That's a 25 times improvement. Users perceive your site as dramatically faster. 3. Origin Shield, reduced backend load. Edge functions can handle many requests without touching origin servers. Authentication checks, rate limiting, caching decisions, request validation, response, modification. Real impact. A media site I worked with was experiencing 1 million requests per hour to their origin. After implementing Edge logic, origin traffic dropped to 100,000 requests per hour. That's 90% reduction in backend load and costs. 4. Data sovereignty and compliance. With Edge deployment, you can process data in specific geographic regions, helping with compliance. GDPR, process EU user data in EU. Edge nodes, CCPA, keep California user data in California. Local regulations, meet data residency requirements. Real-world